Hello, everybody. Welcome to our office hours. Looks like we're still getting some socials going. Okay, we should be good now. Welcome to another office hours for NATS. Thanks for joining us. If you're joining us on socials, we actually mostly do this via Zoom, and that way we can manage Q&A a little bit better. But if you do have a question to ask, you are more than welcome to go ahead and ask that in the chat. I'll be trying to grab chat messages from the various socials as well as different chat messages in Zoom as well. Let's see. We have a couple folks that have already piled in, which is great. I think we're looking pretty good. I'm going to go ahead and jump into the NATS community as well and just remind folks that we are here. We are live for an office hours. Come join us. All right. And I'll do the same thing over here in Canada. We are live office hours. We want join. We might be a little bit lighter today because we have a couple other meetings going on. But today I'm going to be re-welcoming back John Noel Moyne. I think he's on the other side. He's going to hop in for about a half hour to kind of answer any questions or chat about anything. I know John Noel's been working on a lot of things related to the recent NATS server. And so I'm going to go ahead and bring him on, move to webinar. Okay. And when he's ready to come on, he'll also come on as well. Let me pull up the agenda. So we'll be good to go there as well. See, portion of screen. There we go. All right. So I think we are good to go now. Welcome, John Noel. How's it going?
Hello. Yeah, good. Welcome. Thank you, Jeremy, for having me. Looking forward to this. Always fun.
Yeah, this is going to be fun. So I know, I'm sure folks can talk about, NATS server 211, what's to come. Could you give us like I know there's previews out there and we've looked at those before, but could you give us like from your perspective, what are some of the things coming in newer versions of NATS server that we should be able to look forward to?
Yeah, so coming into 11, there's going to be quite a lot of features. Some of them you can already start looking at and playing with potentially if you build the main branch of the NATS server. But there's a couple that I could mention that could be interesting for people because some of them are things that have been asked for by some number of people for a while, actually. And one of them is the ability to essentially have the equivalent of what we call pinned or quote unquote exclusive subscriber to a consumer. So, the JetStream consumers is a server-side thing.
Mm-hmm.
And you have your client applications that can connect to the consumer and get messages that way. There's, as you know, two kinds of consumers, the ephemeral consumers that are typically not shared. So one instance of a client application creates an ephemeral consumer for its own exclusive use, and no one else does. I call that to a bit, to make an analogy to a database in SQL. It's like creating a query and then you iterate through the result set. Your application creates the query and has its own result set that only it iterates over.
Okay.
The other types of consumers are durable consumers. Durable consumers have a well-known name.
Yep.
And that means that multiple client applications can all connect and get messages from that durable consumer. There, the analogy is more like, for example, a view on a database table, right? And one interesting aspect is that if you have multiple instances of an application connecting to the same durable consumer and they're all actively pulling messages, or if it's a push, subscribing to messages from that consumer, the consumer automatically load balances the messages between all the applications currently listening. Great, because that's how you get scalability of your processing of messages in the stream. That's used for any number of things where you typically want that distribution to be done there automatically for you. However, there are some kinds of use cases where instead of having, if you have 3 applications or 2 applications trying to get messages from the same consumer, you want a different mode of operation, which is not one where the clients, the messages are distributed between clients, but rather one client is at a given time pinned, and that's the one that is getting all the messages. The other ones are doing their fetch or their consume or whatever they're doing. They're not getting any messages until the currently pinned subscriber client application goes away. So that's why I call it sort of like a quote unquote exclusive, fetching or getting messages exclusively from the consumer, is that there's only one active client at a time.
Gotcha. And this is kind of so I mean this in one way, just to re-explain it, you have one client that's connected. They're all connected to this via the same consumer, right? And so, this consumer, what the server kind of stores on it is, that we're at, I don't know, sequence number, whatever.
Yeah, it's a view
And
it's a view on a stream, yeah, which has a
exactly.
current sequence number, which messages have been acknowledged or not, etc., which needs to be potentially redelivered, etc., all these things. But
Yep,
essentially, yeah,
we
it's
have
like a
acts, we
cursor.
have filters, we have a bunch
Yeah.
of stuff that the server's kind of keeping track of around this consumer. But this is kind of like, I guess, as part of a set of consumers, this is like a leader of sorts. It's being pinned, and as soon as it goes down, somebody else is going to pick it up.
Yeah, it's been elected if you want, but
Hmm.
it's the currently selected active one. And that's the one that receives messages. So all of them are, uh, you know, if you do fetch, for example, they're just all fetching the same way. Just that some of them, only one of them gets messages, and then the others don't get any messages until such time as the currently active one goes away. Uh, and at that point, the consumer will basically select or elect, same difference effectively, from the remaining clients currently pulling, from this consumer, which one is the one that becomes the active one at that point.
And what is this a good solution for? I could imagine it can be one solution for wanting to guarantee ordering, but maybe still have some resilience as part of it, right?
Yes, correct. So, for example, you want to indeed process messages in order and do not want to have to set the max number of expanding to one, which means that you're sending messages only one at a time.
Mhm.
It's in many cases faster. Obviously, it's faster if you can set the max expanding. You can fetch more than one message at a time, and you can have higher throughput that way. And this allows you to just go faster, and you're not interested in distributing the messages between your clients. You're just interested in having some amount of fault tolerance, high availability of your client processing, right? So you can
Right.
start n instances of it, n pods, whatever you want, and you know that at any given time there's only one that gets the messages. Therefore, even with max expanding more than one, um, it will get all the messages. I mean, at least the initial delivery will be in order, right?
Yes. Okay. Gotcha. Yeah. So depending on how you set some of these up, there's some advantages to this, and this is this is all coming in NAT server 2.11. This
Right.
idea of being able to pin a consumer. Very cool. Awesome. Um, what are some other things that we could be looking forward to?
Couple of interesting ones that go with what we call get operations. So to get messages from a stream, typically most people, or most of the time, you go and get messages from a stream through a consumer, right? So you have a stream, you create a consumer process, consumer on that stream, and then you have client applications getting messages from there. However, there are some cases where you don't actually need to have a consumer. And those are the when you can do what we call a get operation, which can be also a direct get. So what is a get operation? So a get operation on a stream is be able to say, give me whatever message is at this sequence number. So you can address individual messages by sequence number. Great. Or you can actually say, for this particular subject, give me what is the current last message for that subject in the stream, or the first message. And that's useful for many use cases where you do not need to get more than one messages. And you can address the message either by being the last one published on the stream on that subject, or by directly accessing it through its message sequence number ID. And obviously, as you are drawing here, the KV functionality does make extensive use of the get functionality. So when you're doing a get on the KV, you're basically doing a stream get operation underneath the covers that says, give me the last message for the subject corresponding to the key that you're trying to do a get on, right?
Yeah, so this is kind of what drives the KV functionality to make sure those gets are
A lot
fast.
of it,
And
yes.
Yep.
Watch our consumers get our direct get operations. And one advantage direct get operations have, they have a number of advantages, but it's speed, because you do not have to create a consumer and then start fetching on it and then eventually either letting it time out or clearing the consumer yourself. Here, there's no establishment. It's just you send the get request directly and you get your message back. That's one. Second one is you can now access messages on the stream without having to create a consumer. So it's not just the fact that you don't have a first round trip with the server to create a consumer and then you do round trips to get messages from that consumer. Is because the server does not have to maintain any state. Consumers in NATS and Jetstream are stateful things, and it's servers that keep and maintain that state. The state of a consumer being, which is the last delivered sequence number, which ones have been axed or not, those kinds of things, right? So, and sometimes if you, because consumers can have a replication degree like the streams, that means every time you fetch a message, for example, from a consumer, if that consumer is an R3, so replicated over three, servers, that's a raft operation. So long story short, the direct gets are much lighter weight and therefore much faster. Another interesting aspect is there's something which is also leveraged in the KV is you can enable or disable on a per stream basis whether you allow or not direct get operations. So what are direct get operations? They're just like get operations with the difference that the normal basic get operation will go to the server that is the leader for that stream, and that's where the request will be handled. While a direct get can be serviced by any of the nodes that are replicating the stream, not just the node that the server that currently happens to be elected as the leader for that stream.
Gotcha. Okay.
And that provides you even more scalability in terms of throughput, right? Not just because there's no state to establish every time, but because every time you do a get, you don't have to have a consumer raft operation to say, oh yeah, we got this message. And also for the fact that you're spreading the load of those direct get requests between all of the servers. The caveat with this to be to keep in mind in case it matters is that if you have direct get operations enabled, and if you do a put or publish to a stream, and then you yourself right away after that try to do a direct get on the same exact subject to get message back, if it is you're doing those two operations back to back, you could get the old value back from your direct get answer, because the server receives and starts replicating the last put that you did. But let's say 2 of the 3 servers have done the put and they know it's the new version of the value is this. The one is still there, but because 2 out of 3 have done this, the reply to the put request, to publish request has been received by the client, and you do your get, and you could have a little race condition. It's theoretically possible that your get request, direct get request, is handled by the server, which is yet as buffered, but has yet to completely process the last put operation that you did. So you can have a little bit of what I call incoherency in the sense that if you're doing yourself a get after you did your put, potentially you could get still the alt value back.
Gotcha. Okay. And
And
so
if
that's
that's a
one caveat
problem,
with it.
do a get, not direct get operation.
Gotcha. Okay. And then
So
we have some improvements coming to gets as well with like
that's
batches and
right.
stuff, right?
Yes. And that's
Yeah.
what I wanted to get to.
Yep.
But I had to explain gets first.
Yep.
So the gets are there in 2.10 already. The direct gets are there in 2.10 already. Very much leveraged by the KV functionality. And there's two new features coming into 11 are going to be quite interesting with regards to get operations. One is the ability to do a batch get. So rather than saying, give me message from sequence number X, you add sequence number X, you would say, give me, starting at sequence number X, the next 100 messages, for example, if they exist, right?
Yeah.
And that's extremely powerful because right now, to get more than one message back, you have no choice, rather to either you go through a consumer or you have to yourself send 100 different get messages request. There, you can send one and you get back 100. And it's going to be very fast. Once again, very low latency compared to using a consumer and then so creating consumer and then calling fetch or consume, like 100 times to get, or fetch of 100, whatever it is, to get the 100 messages back. That's one. And so you'll be able to say, for example, give me the messages that match. And that's the second part of this, is you'll be able to then say, give me all the messages that match this particular filter.
Mm-hmm.
And the first 100 messages, right, for example, that match this particular filter, or the next 100 messages that match this particular filter starting at this particular sequence number. You can also, you'll be able to do what we call multi-get. So again, a direct get operation that lets you say, give me, for example, the last message and subject foo bar baz, right? And they all come back to you as one, directly from that one single request. So this is exciting because, it's going to be the fastest possible way and the most scalable way to get a bunch of messages quickly from a stream. And sorry for wiping my nose, this allergy season here. Literally, you will be able to have to build and have in the client library the equivalent of a consumer, but that doesn't have any state on the server, right?
Yeah. No,
It
this is
is
really cool, especially because I know a lot of folks are using KVs, and in some ways they're using KVs as kind of a lightweight. I mean, they're using it as a data store, but they're also starting to model maybe some lightweight like database semantics on top of them, right? And so if for instance, if you have a KV, let's just say you're putting a bunch of users in a KV where the subject hierarchy could look something like this. You could theoretically like fetch all of your users by just doing like,
a single
do
fetch with
batch
all
get,
1,000 IDs. Yep.
yeah, or whatever. And I think that can be really cool depending on what your subject hierarchy looks like. You could fetch all those things very quickly.
Yes,
Without, I
and
mean, the alternative was before that you would do either a watch or open up a consumer to the stream and start somewhere and let all the messages flood in and then quit the consumer. But that's like a lot of
exactly.
heavy machinery to pull up and pull down. And at
Yeah.
scale, it's not really going to, at large scales, it's not going to work particularly well if you just have
Well,
10.
it works well enough, but up to a certain point. So a watch is indeed a consumer underneath the covers. The thing with consumers, you can still have a lot of them, right?
Yep.
But as I said, consumers, each time you create a consumer, there's some state that has to be maintained on the server. If it's an
Mhm.
R3 consumer, there's state on 3 servers. And
Yeah.
on top of that, there's overhead of replicating the changes to that consumer, uh, so that every time you get a message from a consumer, there's actually not just you sending a request to a server and getting the answer, but then that server also um, sending the doing a raft operation between itself on the other two servers saying,
Mhm.
I have now delivered this sequence number. And then when you acknowledge, there's another one again saying, oh yeah, this sequence number has now been acknowledged. So it's convenient because, and that's the whole point, right? It's a little bit, again, the design of the idea behind NATS is making it easier for application programmers to write their code. And in this case, you can literally create a consumer and not have to worry ever about having to persisting anything on the client. Very good for, stateless clients, because the client crashes. If it's a durable consumer, the client comes back. It says, get me the next message for that consumer. It gets the next message that it hasn't received yet, right? The consumer has kept state of what the last message was delivered. So great. However, it eventually, is a little bit heavier in terms of latency and is not ultimately not as scalable as doing get operations, and get operations that return more messages as well is again making it faster as well. But so there's two aspects. Is the ability to, literally be able to have millions of get requests going on at any given time, right?
Mhm.
Rather than having millions of consumers created and existing at any given time. So no impact essentially in terms of state and RAF traffic on the servers with this. And then the other aspect is obviously the fact that you have a single request that gets you a bunch of message back. To technically, a fetch request is a little bit like that as well. But
Yep.
again, it's more about the there's many use cases where you're okay with potentially persisting something like what's the last sequence number I have received, something like that on your client side. And if you can do that, long story short, that's how Kafka, for example, scales, right? Kafka consumers
Yep.
do not have any state at all on the servers. They're purely a client thing, right? And they use a Kafka topic a stream, right, to actually persist the state of where the consumers are in sequence numbers. So you could do exactly the same thing here. You could use, for example, a KV to store the state of your client application saying that's the last sequence number I have received. And then when the app comes back up, if it crashes, comes back up, it does a get on the KV, knows what's the last sequence number it has received, and then can do a batch get saying, starting from the next sequence number, give me however up to 100 messages or 2,000 messages that I'm willing to receive at that point. And now you have essentially the equivalent, physically the equivalent of what you do, consumer functionality without having to have consumer on the servers. And that's the
Yeah.
whole reason for this.
Yeah, and it kind of, and this is very much the same with a lot of NATS design, is that like we're allowing you, we're giving you the flexibility to kind of analyze the trade-offs and decide what you want to do. Because, while you can have a lot of consumers, we're talking, when we say a lot, we're saying, tens of thousands of consumers maybe. But if
Maybe
you
a
want to get
hundred
into
thousand,
hundreds of
something like that.
thousands, millions concurrently, this is probably what you'd want to do more of, is store. And to be honest, when it's a completely different model, right? Because when we even talked about here, that even this idea of consumer pinning and this idea of having an active passive, a lot of these paradigms kind of apply to like the cloud, right? Where you have this elasticity and you're pulling up these nodes for HA. But like when we are doing maybe things at the edge, where we might just have like one client running, at the edge, maybe it's an IoT device or something like that, and then we have millions of them. That's a very different model, and like HA is very different, and it's a level of importance there. And so maybe you have millions of clients that are storing their last sequence number on device because they're the only thing that cares about, their sequence number, and they're not splitting the load between, or the messages between other clients. This can be a really good alternative, that's
Mhm.
hyper scalable.
Yeah.
So
And
very,
as I
very,
said, you can leverage the KV to store that client state.
yep.
And again, you can do put and gets. You don't do any watch, no consumers. So it's all very fast. And then before I have to go in for 5 minutes,
Yep.
one last thing that I want to mention quickly, briefly as well, because I also think that's really interesting feature, and that I think is quite unique, is going to be quite unique to us. The idea there is to be able to have consumers, right? Where what to say, it's not exactly like priority, and I'm gonna keep it simple and kind of vaguish, because the it's not quite there implemented right now, though we're working on it at the moment. But the idea is to be able to have streams, right? When you want to use streams, for example, as a queue, right? And you, let's say, have a multiple clusters, right? And you have workers that consume from the stream, right? And if they are within the cluster where the stream is, they get priority, so they get to get the messages as they fetch. But if the number of messages pending on the consumer goes above a certain threshold, then others, other clients that would be, for example, in a different cluster or somewhere else, would be able to start receiving those, let's call them overflow messages, right? So this is quite interesting. The idea being that uh, the thing that you would be able to do with this, as I said, is to, for example, have a deploy a system where you have 3 clusters, east, west, central, for example, right? And you have streams on each one of those, and you put requests for work or something like that in those streams. And you have workers also uh, deployed in all 3 regions. And what you want is, you want to essentially, let's say, the local workers to get the messages until they start essentially kind of falling behind, right? Because there's too much work on that particular region. And maybe on the another region at the same time, there's nothing going on. There's no work for them to get there, right? And they would be able to, quote unquote, steal work from another region.
That's really cool. I didn't even know that was being worked on.
Yes.
So this is kind of like an intelligent routing of sorts, with
Yeah, I
regards to
mean,
like
yeah,
overflow.
it's gonna be like with a threshold and overflow and things like that. But I'm, the terminology may change a little bit.
Yeah, yeah,
But
yeah.
basically, I want to describe a little bit what the idea behind the feature is and what the use case is. And the use case is basically being able to have a consumer, sorry, uh, in one place, and you can say those. You can have clients that come and say, I'm local. I should be served in priority versus others. So, in one word, prioritized uh, getting messages from a consumer.
And is this kind of like an extension of like the pinning mechanism
Yes,
in
yes,
in a way?
yes. They are
Um,
both basically linked, and two sub features of the same general feature. Yes.
yeah, and in a sense, it's kind of like also an extension of, I guess, the queue group functionality. Except I mean, I know that machinery doesn't work that way, but like the ideas are similar. Only if you were to layer on top of a queue group, like this idea that some things will just be overloaded.
Right. This is a consumer thing, but
Mhm.
the consumer may be on top of a normal stream or on top of a work queue stream, right?
Right. Yeah.
So if you're doing this and you're doing it on top of a working queue, you are creating you have the ability to create a distributed queue, right? With essentially localized affinity consumption.
Hmm.
Again, I'm
That's
simplifying a bit the
fascinating.
terms, but that's a really, really cool use case, and one that I think, I may be mistaken. Um, I don't know that anyone else has anything kind of resembling that, at
No,
least
yeah,
in the messaging slash streaming space that we're in.
yeah, well, we're gonna let that cook for a bit. I know that's still something that's actively being thought through and worked on, but that's actually really cool. I had no idea that something like that was
Yes,
being
if you're
worked on.
interested in knowing more, so I mean, the design work is been ongoing for a while. It's basically, I'd say, done. Now, the implementation part is being worked on. And all this will definitely be in 2.11. So there is an PR on an ADR on our architecture and design, reference repo.
Yep.
It's number 42. There's a PR for it.
Okay. Yeah, and just for those who don't know, we all the design decisions around NATS.io goes through this ADR process. And so if you go to github.com, NATS.io, NATS architecture and design, and I'll link it in the chat. You can actually see that you can go through and see all the kind of in-flight design decisions that are being made.
So if you go in the pull request, you'll see there's a pull request for consumer priority groups. IDEA 42, and actually this, actually this one, yes, it's different.
Excellent. Okay, cool. I'll have to read up on this and kind of see.
And then, click on file change and you can see, yeah, exactly.
Very, very cool.
So you see where you have priority groups, which is what I mentioned about. So the idea is to provide priority and exclusive, consumption from consumers.
Very, very cool. Yeah, there's a lot of possibilities with this feature. I'm gonna have fun designing a video on it.
Yes. Oh, yes. This will be great content for you.
All right.
Absolutely.
Well, I know, Jean-Noel, you do have to jet because
Yes.
you have a meeting to be at. But thank you so much for joining us and explaining some of the new fun things that are coming up. I'm going to go ahead and switch over to Q&A. So feel free to ask questions in our Q&A here in Zoom or in the chat. If you're watching on socials, we'd love to answer them. I did have a couple that I'm going to go over. But thank you, Jean-Noel. Thanks for joining us.
Thank you. Always a pleasure.
Yeah, we'll see you another time.
Okay. Bye.
Bye-bye. All right. So Adam asks, will you be doing a deep dive with examples on using NATS resolver with JWT using an external service for the JWT generation? In our case, we're using .NET, so we've been struggling. Adam, this is a great question. And the short answer is yes. I have one video that I'm planning this week, and then the very next video is going to be on our auth callout functionality. And that's kind of what's been aiming to kind of replace the need for having to like use HTTP to go say, hey, give me my JOT. In fact, you can create a service that's kind of has some heightened privileges inside of the system to be able to basically take anything, whether it's a token or whether it's a JWT. It could be a NATS JWT or it could be like anything. It could be your own JWT inside of your system. It can take literally anything, a username and password, and it can resolve those into a set of authorization policies, essentially a JOT. And that's kind of it's a service that basically you write yourself and that does that for you. And then that way all of your clients can connect using any sort of mixed modes of authentication. And your auth service will be the one that kind of decides based on what they pass in. Here's the authorization that they get. So you can do things like you can make it completely stateless. In my example, I'm likely going to do something like a Google auth, where you log in with your Google account and we'll use that JWT to then look at your email and maybe base64 encode it and use that to kind of mint permissions based off your email address. And we'll have kind of an authorized chat, if you will. So there's a lot of cool things that you could do with this. I will admit right now, without like a video, it's pretty low level stuff, and we're going to be making sure that there's going to be better high level implementations of it. But I think once the video comes, it will also be a bit easier to understand. But if you just search auth callout, that's going to be the thing that you want to look for. It's very secure. It should be flexible enough to hit a bunch of different use cases. And so I'd love to do more content on the auth callout for sure. It's something that's been on my list for a while. So thanks for asking that question, Adam. It's a great one. Yeah, Adam. I mean, and in the past that's what you had to do. Like what we would recommend in the past before we came out with something like auth callout is that you would have, let's say you have your NATS server over here, and then you have a NATS client and it needs a JWT, right? Like it's going to try to connect and it can't because it needs some sort of JWT. So you can either mint that JWT with Synadia Cloud or Synadia Platform, or you can use the NSC tool and give that credential over to the client. But the problem with that is it's not very dynamic. You could use things like signing key groups and stuff like that. But the client has to kind of take this credential and like save it somewhere locally. And then when it expires, they have to get another one. So it's kind of, it's nice that everything's, generally decentralized, and that works really well for use cases like Edge and stuff like that. But let's imagine that your clients might be like web browsers, right? Or something else. What we've recommended in the past is that you create this like HTTP based service that goes, and the client, before it tries to connect to the NAT server, would reach out, and that HTTP service, would then mint a JWT based off of the information that it gives. Maybe the client gives its, public end key or something like that, and the HTTP, client gives you a JWT that's been signed. And this works out well in practice, but it's kind of cumbersome, honestly, to expect the client to like make an HTTP request every time and kind of keep track of its own expiry and junk like that. So what the auth callout does is kind of flip this model on its head a little bit. So let me just draw this diagram a little bit better. I can pull it out over here. I'll say that this one's the old way. This up. The old way is to kind of call an HTTP service. The new way is we can use NATS for all of this, which is really nice. New way, which is auth callout. Goodness, if I could type. So this new way, instead of using an HTTP service, we actually have a NATS-based service, which you could even just use like the service layer, but it basically just subscribes to a particular topic and uses request reply. And instead of the client calling out to it, it's going to do something like this. The client is going to authenticate. And like I said, it could use anything to authenticate. It could use username and password. It could use an N key. It could use a token. It could use just MTLS. Like we even give you all like the cert info that comes in, which is really cool. And then this way, your auth service is acting as that resolver for it. So the client just simply connects to the server with whatever they want. The server's like, oh, cool, we have an auth call out configured. I'm just going to pass it through there. And in practice, it just makes so much more sense, because especially like a lot of organizations like using MTLS for good reason. And this way you can kind of like map a map a particular like cert or identity there to like a set of params. So this basically is the thing that constructs the JWT or the permissions. And it works out pretty well in practice. So go give it a go. And I'm also planning on doing a video on this sooner rather than later. So yeah, so like connecting this with Azure AD, like that would be perfect. And in the future, like one of the things we want to do more commercially on the Synadia side is like provide more of these out of the box ones for like, IDPs like Azure AD and stuff like that, that just like works. So you might not have to like write all this stuff yourself. Great question, by the way. Yeah, we've been planning this for a while. Again, it's a little low level, and I want to try to find out a better way to explain it. Yeah, browser gets a token via the auth server vis-a-vis the NAT server. So again, they don't have to call out to something else. Yeah, you could totally do this in a browser, by the way, which is super awesome. And so like what I want to do in a future episode is maybe you're, you sign in. Imagine the client for a second is like a web browser. I'm just going to do a new one here. Imagine the client is a web browser, and what you want to do is first sign in, via Google, like some sort of like OAuth flow, and Google will sign you in. And I'm just going to do this. This signs in via Google. Google gives you back its own JOT. And you can just take that JOT and literally just like throw it into the token field when you want to connect your browser to the NAT server. And then the NAT server will delegate all of that or call out to the auth service. The auth service will be like, oh, I have a token in here that says it's a JWT. Let me open it up and see who's the authority there. Oh, it's Google. And so And so, yeah, you can use the claims on that Google, OIDC thing to say, oh, here's, especially if you asked for it, here's the person's like name, here's their email address, any other like claims that may exist there for OIDC. You can get a lot of other info. But what I was thinking of doing is you take something like the email, and maybe like just for silliness sake, you like base64 encode it so it can be used inside of a subject, and then I could return back to you like a JWT that says like, oh yeah, by the way, you can like publish on like chat dot whatever your email is. um and so like you could do weird stuff like that, which is cool, and that way your auth service is like totally stateless. Now it doesn't have to be stateless. Like this auth service could also be backed by a key value store that's like encrypted, and you can do all kinds of weird stuff there. You could say like, oh yeah, like I know Jeremy's email and I want to give Jeremy these permissions. And so there's a lot of really, really neat stuff you can do with a setup like this. It's a bit more complicated, but it also just like is so much more scalable and allows you to kind of have a bunch of like mixed mode types of auth with it. So I'm excited to talk about this a little bit more in the future, and hopefully I made sense when I brought it up. So okay, we got a couple more questions that have been piling in, which is great. Let me just kind of copy paste some of these and throw them into here. One sec. I've been doing a lot of drawing today. Okay. So and Jonathan Matthews says, what patterns do you see folks using for payload authentication? The same request, but for request reply payload encryption. That's a really good question. And I know some of this has been asked in the NATS Slack even earlier today, / yesterday. But like the idea is like how do you know like something is coming from a certain person? One way you could do this is you could use N keys to like sign a payload. And so you could like, for instance, maybe include, so like a NATS message. Here, let's see. And I think when you're saying payload authentication, that's what you mean, right? Is like you're able to verify payload verification, that you're able to kind of verify like where that a payload was created by somebody who said that they were this person. And a lot of people kind of think about this in terms of like, oh, somebody who's connected. But I think our solution to identity for NATS in general is N keys. And so just for those who don't know, N keys are an ED25519, private public key pair. If I can spell. And so you have your private key, which is obviously just like the client just has it and knows about it. You don't have to share it with anybody. It doesn't exist on the server or anything like that. All the server really knows about are public N keys. And that comes from public N keys for you can look them up for accounts, which are like tenants in our system. And then for users, they actually kind of exist in the connection themselves. So you could query the connection to get this and say, oh, this connection has like is authenticated with this N key. That's one way to kind of verify it. But like all this stuff is distributed too. So like you got to remember that these client connections exist differently on different servers. So like you could just use the N key themselves, not necessarily depend on any sort of state like connections that exist. And I would simply kind of start thinking about, whether or not it's viable for you to say, in a message, I have a subject, I have headers, and I have a payload. And maybe I take my payload and I, sign it. And I have my, public N key in the header that I could then verify that it's been signed. So that's one way to kind of do it. You could kind of treat it just like you would a JOT with some sort of signing stuff and just include all the relevant information around signing in the headers. That's one way that you can go about doing it. I haven't really, in my experience working with customers directly, I don't think we've come across something where we'd had to sign it. The closest I've been is I played with the idea of like having a WASM module that like somebody signed and sent over and then verified, but that wasn't necessarily in the context of like everything's in the message. It was more like, oh, here's my N key. And so you can just verify it yourself. But yeah, I mean, there's nothing stopping you from putting this in a header, I think. So. There's a good follow-up question that Jonathan asked is like, so do you see folks reusing the same end keys that they use for a connection or as part of their payload level authentication? They can. I mean, there's nothing like stopping them from doing that. You know, you would just have to consider like what identity means for you, and also think about like what does it look like to if you need to like re-roll keys, rotate keys, like are those things similar? You know, I guess my first gut would be like, sure, reuse them because identity is identity is identity. And you could accomplish both of those tasks with that. And so the cool thing about N keys is that you can use N keys just separately, or you can use N keys without JOTs, or you can use N keys with the actual auth callout like we just talked about. So I feel like they're the more flexible one because it does have full, you know, it does have a kind of full identity and signing behavior that you can express. And so you can take that same identity that's totally decentralized, and you could take it beyond just like authenticating with the NATS server. Is there a way for a consumer to be definitively told the public key identity is part of the message header by the server, so it's definitely correct? I don't think so. And to be honest, like this kind of gets into a whole other topic of validating streams, which I've kind of had this people ask me all the time. This gets into a whole other topic, which is similar, but I think it's actually a good topic, which is like, and to be fair, like we have this idea of like a schema registry coming. It's something that we want to plan on and work on. We don't have any plans on exactly what it looks like yet, but it's certainly been talked about. But like as soon as we get into the topic of schema registry, we're like, okay, so why do people want the schema registry? Do they want it to be able to like, is it for governance across an organization, or is it that they want better discoverability, or is it both? Are they trying to streamline their development process? Those are all good questions to have. There's a lot of trade-offs when trying to adopt something like schema registries, right? If you want discoverability and velocity, what a lot of folks do is they have schema registries that are really like client side only, right? So you have a client that's then like saying, oh yeah, I want to send data to this stream. So can you like give me what the schema is so I could just like magically encode what I want? And then I know as a client that I'm sending stuff to the right, I'm sending the right stuff to, there's going to be a stream right here, that I'm sending stuff to the right stream, right? And there's nothing in a lot of these systems, there's nothing over here, like in the server land, that's necessarily like validating or ensuring that payload is right. It's just kind of happening by convention. Now, what a lot of people ask is like, well, why don't you say we're going to validate or ensure a particular right thing here? Because it gets tricky. What happens when you have multiple versions of a schema now, and what happens when you need to migrate all of these things? What happens when you have a lot of things at the edge that you can't migrate? And so what I kind of recommend is that like when you start thinking about things like trying to verify something before it goes into like a pristine state, that you kind of lean into the fluidity that NATS already gives you, right? And this is one of the really nice things about NATS in general. I'm going to say schemas and validation. Which is like, this is what I'd recommend to lots of folks is like, maybe you have two streams and one is kind of like your ingest stream. You can even treat this as a work queue of sorts, where your clients maybe aren't trusted. Maybe they're trusted enough to like send data here and you're like totally cool with that. But if you want like your pristine stream that's going to maybe act as your system of record, there may be some reconciliation that needs to be happening anyway, where you have, again, this gets a little bit more complicated, but you have some consumer that's pulling these off and then saying, what do I want to do here? Do I want to, validate, verify, migrate, clean up, discard? What do I want to do with all this? Because like at the end of the day, when you have a certain amount of scale, whether it's a bunch of moving pieces, a bunch of microservices, a bunch of teams, alongside a changing schema, like it's really hard to try to control it at the perimeter. It just really is. Like, and so one architecture I'd recommend, which is again a bit more moving pieces, but is like you want to create your pristine stream at the end of the day. So it's maybe your system of record, but like at some point you're going to have to like rectify what that looks like. And so you kind of think about it in that way. I hope that makes sense. But like that's one way that you can kind of look at that pattern. And so in a lot of ways, you're still using a schema registry, but you know, it's something that yeah. So like Arturo says, I think schema validation should be delegated to the client. Yeah, for sure. Like I think making sure there's a good way for clients to get things right, and also like be able to adapt to change like versions. Like that's why we do like the idea of keeping a schema registry on the client side. But you also just have to be defensive in general with data, and like assume that somebody's going to send you garbage at some point. No matter how much control you have over it, somebody's going to send you garbage. So there's going to be you're going to have find some way of being defensive. And either that means you're going to be very defensive upstream in your consumers of whatever this is, or you can be defensive and, you know, pre-process these essentially before they kind of go into a stream for more broad consumption. And so that's just kind of one way to think about it, and one way I'd recommend it. And again, the cool thing is like modeling this in NATS is actually like pretty fun and straightforward. And it doesn't require like a ton of moving pieces. So that's kind of my overall thoughts on schemas. I totally agree with Arturo there that like who just commented on Twitter that schema validation really should be on the client side. There's not a lot of better ways to like adapt to changing versions and stuff like that. And so when we do design a schema registry, like our plan is to really make this client side for the most part, not try to shove this idea of governance of what ends up in a stream into like this scope of schema, if that makes sense. Again, there's other ways to go about doing it, but that's kind of our opinion right now. Okay, I think there are a couple other questions. And I know we just have a few more minutes. So again, feel free to jump in, ask questions, or if there's any kind of things that you guys want to know more about. We haven't even gotten to articles yet, but this is super fun. Are there any plans to implement a pre-message hook, as in like before the server sends a message to a sub, a server-side hook? So yeah, TypeCampo, that's an excellent question. It's something we've considered. We just don't know. You know, anytime we open up something like that, we open up a new surface area of like large performance considerations, and we're already pretty heavy in that space, as you can already tell, where you know there's a million variables to consider with performance. But like the auth callout that I just explained was just kind of like one of those tests for us, was to say, hey, like, is this model a good one where we can securely essentially delegate to a service request reply to do some sort of like transform on a message or anything like that. Again, there's an inherent cost to it, mainly because, you know, authentication is generally pretty safe. It's not like we're going to have clients authenticating, you know, millions and millions of times a second. And so we felt like it was a good trade-off to say, yeah, we'll go over the network to be able to like delegate this. But you got to understand that like this is also still really sensitive to latency. So if like you want your authentication to, you know, work well in a global deployment, you got to deploy this auth service pretty much everywhere a NAT server is, or maybe everywhere a NATS cluster is at least. And so that can get challenging. And the same thing could be said about callouts for like message transforms, is that, you know, you would have to have a service that that can live close enough to the NATS server, maybe even on the same box or through a loopback interface. So we're not going through too much of the network stack or over, you know, an actual network. But you know, that does require you to deploy this service everywhere a NATS server is, which can be challenging. And we've also kind of experimented in the past with like, well, what does it look like to put like WASM in here? And as of right now, like WASM, to take a step back, NAT server is written in Go. We try to avoid CGO at all costs because trying to maintain those across multiple architectures can be complex. It can have the potential to bloat the client, and just create new problems in terms of builds. And so for portability's sake and for ease sake, we've been really trying to avoid putting Sego into NATS server. And so all of the C-based WASM implementations are off the table for us right now. We've tried like WAS0 and like the pure Go based implementations of WASM, and we just haven't seen like honestly a loopback interface. It leads to similar, if not better, performance, and it's just not in our minds. It's just not worth the trade-off yet. We're interested to see how stuff like NEX that we're working on kind of continues to mature, because maybe it will be easier to just put things closer to a NAT server via NEX. And that's kind of one of the things that we're considering and going for. But like performance is just a huge consideration. Imagine having, and it's not clear that it's like, oh, imagine just having middleware inside of a stream, and that like it's very easy to put in there, and you just completely tanked performance because something that took literally 0 time now can incur, multiple milliseconds of latency each time. So we'll have to see. We'll just have to see. It's not necessarily there's been nothing that's been like we absolutely need to do it this way. No good option has necessarily popped up, but we are liking this call out mechanism, especially for auth, and maybe there's going to be some better ways to go about doing it in the future. But yeah, performance is already a beast, and it's one of our biggest wrestling points right now. And it's not because NATS sucks performance wise, because people keep using NATS to do crazy things, which is awesome. But it means like our focus on performance has been just that. So yeah. On-demand transforms and conversions. Yeah. And I think the other thing that like I want to look at is obviously like some of you have heard the news about Benthos being bought by Red Panda. And I know a lot of folks have been using Benthos in the past, and we're continually just like evaluating, hey, what does it look like for us to support more connectors in NATS, but both connection and transform. So it's similar to what Benthos has done, and we might even continue to just leverage Benthos. But this idea that like, you might have some sort of transformation that you want to happen, and it goes through one stream, not another stream, because it's easy to have multiple streams in NATS. And then, you have some sort of connection or transformation that's happening inside of like some stateful, service that's easy to deploy, that has easy configuration, things like that. So we're playing with some ideas. And it's not an easy problem, but it's something that we do want to solve for. I actually have like a real quick, we're at end of time, but for those of you who have used Benthos, throw this up in the chat. I'm curious to know, okay, I'm actually just going to ask the question here. Questions about stuff like Benthos or stream processing. What do you like better? There's a bunch of trade-offs here. Do you like being able to write YAML, or do you like being able to write in like a language of your choice? Or do you want a language that's like one language, but one that everyone knows, like it's JavaScript? Now, it might not be JavaScript from a performance standpoint. I'm just saying, like, you want to define your stuff with logic, or do you want to define your stuff with pure config, right? I'm curious about that, because I've been thinking, I know some people, some people hiss at YAML, some people even hiss at JavaScript, but I've been kind of thinking on my own of like, well, what if we could define some of this stuff in JavaScript and maybe it's even just Benthos itself, right? Where you can literally just put a JS file and treat it kind of like a serverless application. And basically you can define in JS, it's kind of like, I don't know, workflow. I'm writing code in here, but workflow is like, workflow.input is workflow.input is, I don't know, NATS Jetstream. And then I could do other stuff here. And then if I wanted to, if I wanted to do some form of transform, I don't have to. One of the problems with Benthos, in my opinion, I mean, not in my opinion, I like bloblang, but like a lot of people don't, want to learn another language. So what if you could do some sort of transform in here where you're just essentially calling out to JavaScript to, not message. You're essentially just calling out to JavaScript or V8 to do all of this. So all of the heavy lifting and machinery and moving the data, it's still going through like Go at the end of the day. Like you could actually, not call out to JavaScript at all, but if you wanted to, you could just write a little bit of JavaScript to do your like transform stuff here. Does that sound stupid, or does that actually sound pretty cool? Yeah. Like I know a bunch of databases have been like either adopting WASM or like JavaScript to do stored procedures, and I feel like the ecosystem that thrive more are the ones that use JavaScript. As much as people are like, I don't want to write JavaScript, everyone kind of knows how to write JavaScript enough. So, um, yeah. And Jonathan, you mentioned Q. I love Q, by the way. I've used Q so much. And but like there's still a lot more that I want tooling wise. I want a Q LSP and stuff like that. And so I'm kind of opened up to all these ideas now of like, what does it look like for us to do connectors and transformations and stuff like that. I want it to still feel declarative, but I also want it to feel like there's good like editor support that anybody can just pick it up and use it. And there was a lot of that stuff that exists in Benthos. But maybe we could take it a bit further, right? And kind of make something of our own while still supporting the open source ecosystem. So, and yeah, like full TypeScript support as an example. Like it would be cool to have autocomplete on all this stuff. And for Vim to tell me like this, that I'm a Dumbo. So anyway, yeah. Don't add another language. Like that's the thing. Like, and that's one of my challenges with bloblang is it's nice that it's this own little mapping language, and there's some things that it does really well in Benthos. But honestly, there's times where I'm like, I just want JavaScript. Like if I could just write JavaScript for this, it would be fine. And so I've been playing in the background a little bit and testing and like calling out to V8 compared to bloblang. Like there's not a lot of difference in performance there. So yeah, part of me is wondering what that could look like. Yeah, I haven't tried out Qplease yet. I know it's recent, but I think there's something interesting here, and I'm probably going to be scratching my head a little bit on this a little bit more and being like, maybe do people want to use JavaScript to define, connections to stuff and treat it like serverless and have it really integrate really well with our technologies like Next and stuff. So just thinking out loud. All right. Well, everybody, thanks so much for joining us and for playing along and asking some good questions. I know we didn't get to everything, but we do these every week now, so we'll have a more fun time. And if you want to talk more about this kind of stuff, maybe I can even just go on stream and do some live coding, and we could talk through some of these, because this is stuff that we want to work on and try to bring more value to the community in this way. So thanks for joining us. Thanks for asking questions, and I will see you next week. Bye-bye.